Welcome to the NLAB workshop. My name is Nick, and I'm here to teach you how to build your very first circuit, a light, in less than 15 minutes. Along the way, you're going to learn the basics of electronics. Let's get started. There's something magic about electricity. We can use it to make colors and sounds, and make things move. Controlling electricity is like having a superpower, but there is no magic in this wand, just some clever engineering. Anyone can have superpowers if they learn how to build circuits. By doing so, we can enchant everyday objects and make them smarter and better for the world. We use electricity to cook our food, to move our cars, and power the internet. But we need more people to understand how all this works if we're going to channel our superpowers to save the world. But let's start with something a little more tangible. So in this lesson, we're going to take a look at our NLAB kit, get ourselves set up to work, and build our first circuit. Let's start with a quick look at what's inside the NLAB kit. You'll find a breadboard, which is not made of bread, so please don't eat it. In fact, don't eat anything from the kit. A colorful bundle of wire, a pair of wire strippers, some baggies of various components and doodads. We're going to talk about these in future videos and use them to build some pretty cool stuff. Last but not least, the NLAB, the device that takes all of the machines in an electronics lab and makes them fit in the palm of your hand. We will use these parts to learn how to design and build circuits. It all starts with the breadboard. The breadboard is a sandbox of sorts, where you build and test your design. If it doesn't work as you expect, you can take it apart and rebuild. Engineers do this until they're sure the thing that they're developing works and that customers will like it and want to buy it. We call this process prototyping. When you are prototyping, you can do no wrong. Try out all of your cool ideas, and if something doesn't work, no big deal. Figure out why and continue to explore. This is what being an engineer is all about. Speaking of which, let's start engineering by setting up our mini electronics lab. Your NLAB may arrive plugged into the breadboard and ready to go. But in case it isn't, take your NLAB and notice these pins sticking out. These will connect the NLAB power and signal to the breadboard. Align two sets of pins with the holes of the breadboard in row 6 and the top of the printed circuit board with the top of the breadboard, and push it. The NLAB comes with a USB-C cable to connect the NLAB to your computer. Plug the cable into your computer and then plug the other end into the NLAB. Green lights will turn on. Locate the power button. It's this white button sticking out over here. Press the power button and you should feel the button click, and the red and blue lights will turn on. Now that we have a power supply, we could build a circuit starting with the most important components, wires. You're probably familiar with these. They carry electricity from the power plant around our city, through our homes, and to your devices. But when you touch a cord plugged into an outlet, you will get shocked, even though that wire could be carrying a lot of power. That's because the wires are insulated. They have a coating on them that protects not only you from getting electrocuted, but also prevents the wires inside from touching each other. You'll notice that the plug part of the wire does not have any insulation. It's just bare metal. That's because metal is an excellent conductor of electricity, and it needs to make contact with the source of power in order to transmit the power through the wire. In order to make connections between wires, we need to remove a bit of insulation to expose a bit of metal, which will then plug into a power source. This is called stripping a wire, and we'll use our wire strippers to do this. Take out your bundle of wire. Find the red wire. We're using red because electrical engineers use this color to indicate power entering a circuit. Use the cutter portion of the wire strippers to cut off about 2 inches or 5 centimeters of wire. We need to strip off the insulation from both ends of the wire so that the metal part of the wire can plug in and touch the metal inside the breadboard under the plastic. So you're going to want to hold up the wire to the breadboard like this to measure the amount that you're going to want to strip off. It's the same as the depth of the breadboard. The trick to stripping a wire is to choose the correct alligator tooth to take off the insulation without also cutting the metal inside. This may take some experimentation. First, I'll try this one. It says 20. It didn't do anything at all. That's because the hole was too big. Okay, let's go over to the other side. I'll try the 30 hole. It took off the insulation, but it also nicked the wire. It's going to break there. So let's cut off that end and try one more time. I'm going to try a middle hole. I'll try 26. And that took off the insulation really nicely without cutting the wire. So here's a tip. When you have the wire in the alligator teeth, give it a little wiggle. The insulation should slide right off. If it's not sliding, it's because the hole is either too big or too small. So I did the same to the other side. Let's make one more wire of the same length, this time black, to indicate power leaving the circuit. So I'm going to put one end in 26 and just slide off, and put the other end in 26, slide it off. Now we have two wires stripped on both ends. Next, take out your resistors. They look like this, and they control the current flowing through a circuit. I'm going to explain how in kind of a weird way. Using a balloon. Maybe you've seen electricity in action with a balloon before, when you do this. This is what we call static electricity, but that's not actually what we're going to use this balloon for. Instead, we'll use the balloon to represent a battery. We're all familiar with batteries. They provide power, and when they run out, we either need to recharge or replace them. Let's say that this is a battery, and we see that it's out of juice, so we'll recharge it. We've now filled our battery with power in the form of energized electrons, these tiny particles that hold charge, the same charge that you use to charge your devices. As you can see, the air inside this balloon is dying to escape. And as soon as I allow the air out, that's exactly what it's going to do. The same is true for the charge inside a battery. It has all this energy and it's dying to escape from the battery to give power to something. This energy exists as pressure inside the balloon, which in the battery we refer to as voltage. It's the pressure of all those electrons trying to get out. The flow of pressurized air out of the balloon represents the flow of charge, or electrons, from a battery. The flow of charge is called current. To control the current coming out of the battery and prevent the power from running out quickly, we use a resistor. Just like squeezing the balloon's neck, to control the flow of air, a resistor limits the flow of current. For this project, we're going to use a resistor in your kit that has the pattern orange, orange, brown, gold. Once you locate one, take one resistor out of the tape and set it aside. Finally, we'll locate our most important component in the light circuit, the light itself. In electronics terms, it's called an LED, which stands for light emitting diode. Find one that is red in color and add it to your pile of parts. Now we have all the components we need to build, but there's still one more thing we need to do. If we're going to build a circuit, we need some instructions to follow. Let's draw the circuit first so that we have a sort of map to reference while building. We call this a circuit diagram. We'll create a light circuit which requires three things: a battery, or some kind of power source, a resistor that controls the brightness, and the light itself. You'll notice power sources, like batteries, have a plus end and a minus end. Power flows out of the battery from the plus end through the circuit towards the minus end. So let's start with the positive end. The battery, in this case, supplies 5 volts from the laptop, so let's rate 5 volts at the top. Then let's draw the next component, a resistor, which we represent with a zigzag. Then the light itself, which looks something like a triangle with a line. Finally, let's end at ground, or 0 volts, which in the electronics world we refer to as ground, or GND. Let's draw dots at the connection points of all these components. These are called nodes, which I'll explain more about later. Now that we have our map, we're ready to build our first circuit to turn on a light. So let's get out our sandbox, the breadboard. We talked about how important these are in prototyping overall, but how do they actually work? Well, to show you, I'm going to have to destroy this a little. By the way, don't do this yourself. It's not pretty, and you can't really use the breadboard if you do this. This is what the inside of your breadboard looks like. Flipping to the top, we see 5 holes in a row. On the other side, we see that those 5 holes lead to one metal bar. So you can think of all 5 holes in one row all connecting to the same metal bar, and these metal bars conduct electricity. They're the perfect place for electrons to hang out. For simplicity, let's build only on the right side of our breadboard for this exercise and ignore the left side. So let's start by making our first connection. Let's take the red wire and place one end in the 5-volt column, and the other end in any hole on the right side of the breadboard. Just pick one. Great. So now, whichever row you picked, the metal bar inside that row is charged with electrons coming out of the 5-volt line, and those electrons are coming from the battery in your laptop. What's next in our circuit diagram? The resistor. We see that the resistor and our first wire are joined together on the same node. How this looks on the breadboard is that anything joined by a node means that they are touching the same metal bar inside the breadboard, meaning they share a row. So how do we make a resistor and the wire share the same row? You plug one end of the resistor into any hole in that row. It doesn't matter which one. That's because the metal in the bar goes across all of them. Once you do that, the electrons rush out into the resistor and they're ready to go into the next thing. What is the next thing? The LED. And we see that there's another node between the resistor and the LED, so let's put the other end of the resistor in any row to start a new node. Before we plug in our LED, let's take a closer look at it. You'll notice that one leg is longer than the other. This is because the direction that we plug the LED in matters. The current will not flow if it's not plugged in the right way. That's because the LED is a semiconductor and it doesn't let current flow both ways. As we will see in the future videos, the special properties of semiconductors will allow us to design a lot of cool circuits. But this coolness makes it a little bit more complicated because we can accidentally plug the LED in the wrong way and it will not light up. So we plug the long end of the LED into the same node or row as the resistor, and then we use the short end of the LED to start a new row. Finally, let's take our black wire and complete the circuit by bringing the electrons home to 0 volts. Your circuit should now look something like this. Press the power button, and voila! The light turns on. Congratulations! You've built your first circuit. If the light doesn't turn on, make sure that the power is on, that the LED is pointed the right way, that the resistor is orange, orange, brown, gold, and the node connections from the circuit diagram match what you built in the breadboard. Great job on making your first circuit. You have used your NLAB to get power into the breadboard, you drew a circuit diagram, and built a prototype light circuit in the breadboard. You've officially taken your first step into the world of circuits. I hope this inspires you to like and subscribe, and keep going. I have more exciting circuits and projects waiting for you.